You know, every single year, something incredible happens right over our heads, and most of us barely even notice it. We're talking about billions of birds making these epic journeys that honestly seem completely impossible. This is one of nature's greatest mysteries, bird migration, and we're going to figure out how they pull it off.
So, just to give you an idea of the scale we're talking about, let's look at the bar-tailed godwit. This bird flies non-stop from Alaska all the way to New Zealand. That's over 11,000 kilometers, or almost 7,000 miles with no stops. No food, no water, no rest, just flying. And that really is the core question, isn't it? How? How can a tiny animal that often weighs less than your phone fly a third of the way around the world and land in the exact right spot year after year? I mean, think about it. They don't have a map, they don't have a GPS, so what's their secret?
Okay, so here's how we're going to break this down. First, we'll get a handle on just how massive these journeys are. Then we'll look at their built-in alarm clock that tells them when to leave. After that, we'll dive into their amazing navigation toolkit, see how they stay on course, and finally, put it all together to see how this incredible system works and what it all means.
Okay, so let's start with the sheer scale of this whole thing. This isn't just a few birds deciding to fly south. We are talking about billions of animals in a coordinated movement across the entire globe. They cross oceans and continents to arrive at the exact same spot they were the year before. The precision is it's mind-blowing.
So the first piece of the puzzle has to be timing, right? It's not like they get a pop-up on their calendar saying, "Time to migrate." So how does an entire species, spread out across a whole continent, know to leave around the same time? Well, it all starts with an internal trigger. The main signal is something called the photoperiod, and that's just a fancy way of saying the changing length of the day. As the days start getting shorter in the fall, or longer in the spring, it literally triggers a chemical reaction, a hormonal shift inside the bird. It's like nature's own built-in calendar telling them, hey, it's almost time to go. So these hormones kick in and create this fascinating behavior that scientists actually call migration restlessness. The bird gets agitated, it gets antsy, and it feels this powerful, overwhelming, pre-programmed urge to fly. And not just fly anywhere, but to fly in a very specific direction. It's the starting gun for their journey.
All right, so the internal alarm clock goes off and they know it. Now, for the truly amazing part, how in the world do they know where to go? Well, it turns out they don't have just one tool for the job. They have an entire toolkit of built-in compasses.
Scientists have figured out that they have three main navigation systems. They use the sun as a compass during the day, they use the stars as a compass at night, and this one is just incredible. They have a magnetic compass that can actually sense the Earth's magnetic field.
And what's so cool is that they're prepared for anything. In the daytime, they can use the position of the sun, and they have an internal clock that's so good they can adjust for the time of day. But what happens at night, or on a super cloudy day? That's when the backup systems take over. They can navigate by the stars, and they can rely on their secret weapon.
And this, right here, is where things get really wild. Birds have an invisible sense, a kind of superpower that we humans just don't have. They can actually perceive something that is all around us all the time, but is completely hidden from our senses.
They can sense the Earth's geomagnetic field. That's this massive invisible field of energy that our planet's core generates. We need a physical compass to even know it's there. Birds, they just feel it. Some scientists even think they can literally see it. This gives them a perfect, all-weather, 24/7 compass to find north, no matter what. But, you know, a compass just points you in a general direction, right? It tells you go north, but it doesn't tell you to turn left at the big mountain. To get to a specific address, you need more detail. So how do these birds fine-tune their route and make sure they stay on track?
This is where they start acting like seasoned pilots. The experienced birds, they use visual landmarks, things like coastlines, rivers, big mountain ranges, to make tiny course corrections. They actually remember the route from years before, and they're absolute masters at adjusting for things like crosswinds or flying around big storms.
So the really important thing to get here is that this isn't just one simple trick. It's a whole system. An incredibly complex and interconnected system where all these different parts have to work together perfectly for the bird to make it.
So let's just recap the whole toolkit, right? You've got the internal clock telling them when to go. You've got the sun, star, and magnetic compasses telling them which way to go. And you've got this built-in map of landmarks for all the fine-tuning. It's the whole package. It's got backups for the backups. It's a completely self-correcting navigation system.
And when you lay it all out like that, with the main systems, the backup systems, all the cross-checks, it makes you ask a pretty big question. The source material we're looking at puts it like this. Could something this complex, this beautifully integrated, really be just a random accident?
And that question leads to a specific viewpoint. For a lot of the people who study this, the sheer elegance of it all is just hard to overlook. The way the clock and all the different compasses and the memory just work together perfectly inside a tiny bird's brain, well, it leads them to think it looks less like an accident and more like the work of a brilliant designer.
But no matter where you land on that question, one thing is absolutely for sure. Studying bird migration should just fill us with wonder. We've seen how they know when to go, which way to fly, and how to stay on course. It really makes you stop and appreciate the incredible intelligence that's just built into the natural world.
I mean, think about it this way. For us to do what a bird does, we'd need a phone with GPS, a separate compass, a watch, a whole bag of gear. The bird? It has all of that and more, just built right into its brain and body, and it all works automatically.
It's basically a self-guided, self-powering, self-programming drone that weighs less than a pencil, and it's made out of organic materials. When you think about it like that, you realize just how spectacular this piece of natural engineering really is.
So here's the takeaway. The next time you see a tiny bird just sitting on a wire or a branch, just pause for a second. Don't just see a bird. See a master navigator, a world-class athlete, a tiny biological miracle carrying an ancient invisible map inside its head. And maybe just ask yourself, where has it been and where is it going next?